Lesson 11.4, Volume of Pyramids and Cones. Now this one's going to get a little tricky, but it's not going to be too bad because luckily the formula for pyramids and cones for calculating the volume is the same. So we're going to look at pyramids, we're going to see how it comes about, the formula is made, and then we're going to also translate that over to cones, and you will see. Now, pyramids, a little bit of review, a little bit of definition and some terminology here. Pyramids only have one base. Now I know before in some shapes we talk about bases could be moved all around, but in a pyramid, because of the fact that the other point up here is the apex, this is the corner where all those lines come together, you can only have one base. All of the faces are triangles. You can see the triangle here and the triangle here. The base is not. The base is a square or a rectangle. And then the apex. The apex is the top. That is a vertex up there, but it is the highest point. It is called the apex. In a cone, you have a circular base. The base is the shape of a circle. It only has one curved surface. That one surface wraps around, and it has one vertex up here, and this one is also known as the apex. Now, a lot of times we draw cones upside down because it's easier to envision the base down here. Remember back when we learned about the area of a triangle formula. The reason the area for a triangle is 1/2 base times height is because a triangle is 1/2 of a rectangle. Now, put that in your brain, tuck it away for a moment. With pyramids and cones, we're going to work with this same volume formula. We're going to deal with the area of the base, that's what big B is, and we're going to multiply it by the height. Okay, but with a pyramid, and this is a little too complex to draw in a 2D setting, so you're just going to have to trust me on this. A pyramid, if you put 3 of them together, and these are supposed to be 3D pyramids, you know, this goes into the background back here, it has, you know, all kinds of bases and vertices and sides and all that. If you put 3 of the pyramids together, then you get a rectangular prism. Just trust me on that, it's too hard to draw. So, if you get a rectangular prism, then the volume would be big B times h. But, since we put 3 of them together to form that, if you want only one of the pyramid's volume, then what you do is you take this formula right here. You take 1/3 times the area of the base, big B, times the height. So the new formula is not volume equals big B times h. It is now 1/3 times big B times h. Now, big B still means the same thing, the area of the base, and h still means height, but it's just new 1/3 added to that. You have to think of it. So the volume of any pyramid, here it is. Volume equals 1/3 times the area of the base times height. Okay, so let's put this to practice. Here I have a pyramid. It has a 4-inch square base and a height of 9 inches, and the height drops right down through the middle, right to there. Here's our formula: 1/3 times big B times h. So what you need to do is calculate the area of the base, find the height, and multiply these 3 together. Pause the video, try this problem, and see what you get as an answer. Then come back and hit play, and we'll see if you got what should be. Okay, so you start with 1/3, and you're going to multiply it by the area of the base. Well, our base is a square, so we're going to take 4 inches times 4 inches, and that gives us 16 inches squared. And we're going to multiply that by our height, which is 9 inches. So we got these 3 now that we're going to do. So, we need to take 16 times 9, that's 54, carry the 5, 9 plus 5 is 14. We have 1/3 of 144 cubic inches. So we have to figure out what 1/3 of 144 is. So we take 144 and divide it by 3. We gotta figure out what that can be. 4, subtract away 12, bring down the 4, that gets you 8. So the volume of this pyramid, is 48 inches cubed. A cone works along the same basis. It uses the same formula, which is good. We don't need to think about a new formula. We can just use the one for pyramids. Now, the thing about a cone, though, is it has a circular base. So we got to remember our area formula, which is pi r squared. Our radius is 3 centimeters. That means 3 centimeters is going to be 9 centimeters squared. Our height is 8 centimeters. So 9 times 8 is 72 centimeters squared. And then we're going to calculate 1/3 of that. 1/3 of 72, 2 up there, is 24 pi centimeters cubed. So the only thing you really have to remember out of this is your formula for any pyramid or cone is that right there. 1/3 times the area of the base times the height.